state without proof the division algorithm. Let a and b be integers, where b is not equal to 0. So notice that a and b can be positive and negative, and a can be equal to 0. Then there exists unique integers q and r, so that a is equal to bq plus r, and r is between 0 and absolute value of b. R could be equal to 0, but r must be less than the absolute value of b. Okay, so this is the statement of the division algorithm. So let's just go over a few examples of this. So for example, if a is equal to 13 and b is equal to 4, then the quotient would be equal to 3, and the remainder would be equal to 1. So that would be, if a is equal to 13 and b is equal to 4, then q would be equal to 3 and r would be equal to 1. If a is equal to negative 13 and b is equal to 4, then what we would have is that b would be equal to negative 4, and r in this case would be equal. So here we have negative 16 plus 3 makes negative 13. So that would be, notice that it's not as simple as just simply to make r equals negative 1. You don't just simply multiply the top equation by negative 1 to get negative 1 down here, because r must be positive. If another case, if a is equal to 13, but b is equal to negative 4, then the q would be equal to negative 3 for 12, and then the r would be equal to simply 1 again. Let's suppose that a is equal to 0. So 0 equals, say, 8 times something. So in this case, the remainder, the quotient would be 0, and the remainder would be 0. In a case where r is equal to 0, if we have 24 equals 6 times something, then clearly the quotient would be equal to 4, and there is no remainder. So r is equal to 0. And as pointed out in class, this is the principle behind doing long division from elementary school, and also the principle for converting a fraction into a mixed fraction, improper fraction into a mixed fraction if the numerator is greater than the denominator. So this is the theorem that allows that simple operation from elementary school.